equation of chord of contact, equation of polar. Now, please let us have some background about this. If you take chord with a midpoint, is S1 is equal to S11, S1 is equal to S11, and pair of tangents, last but not the least, pair of tangents is S into S11 is equal to S1 square. What is pair of tangents? Pair of tangents, equation of pair of tangents drawn from an external point to the parabola is given by S into S11 is equal to S1 square. S into S11 is equal to S1 square. Now I presented most of the important results, and let me take you tangent and normal once again, as it is most important. Let me show you tangent and normal, some of the important aspects of tangent normals. What all we did is standard equation, focus, parametric coordinates, tangent equation, and chord of contact equation. Chord of contact equation and pair of tangents, all these normal and routine things. Now we just take up tangent and normal to a parabola at t. This is important. Tangent and normal to a parabola at t, that is 80 square 280. Lot of problems are being asked on this. So I am taking up tangent and normal to a parabola at 80 square 280. Now let us take each step. Most of the 7 marks questions come from this only. So please have a look at this. Now let us take this in detail. Now I took the parabola y square is equal to 4ax. Okay, this is the parabola, and this is the shape which we don't want, not important. P is the point, 80 square 280 given in the parabola. This is the tangent there, and this is the normal. These are the tangent and normals. How do we find tangent and how do we find the normal? Okay, tangent equation is S1 is equal to 0. That is y into y1 is equal to 2a into x plus x1. Please look at this. Y into y1 is equal to 2a into x plus x1. For all curves, this is the benefit. Circle, ellipse, hyperbola, parabola, in all the 4 curves, tangent equation is S1 is equal to 0 only. So this is what S1 is 0. Y square is written as y into y1. This is half 2a into x plus x1. But the given point is 80 square 280. Let me put 80 square 280. Y is equal to 280. 2a into x plus 80 square. Number of derivations. If I leave 2a, yt is equal to x plus 80 square. Yt is equal to x plus 80 square. This is tangent equation at the point t. Yt is equal to x plus 80 square. If you look at this please once again. Yt is equal to x plus 80 square. If you look at this, and let us take normal equation at the same point. Normal equation. Please look at this. Equation of normal is first of all, my tangent is yt is equal to x plus 80 square. We don't actually forget this. Yt is equal to x plus 80 square, and the slope of this is, slope of the tangent is 1 by t. How did I get that? If you write this as y is equal to mx plus c, that is divided by t, you get 1 by tx plus at. So this is the slope, m is 1 by t. This is tangent slope. Therefore normal slope is minus t. Why? Because normal and tangent are lines perpendicular to each other. If you know the slope of tangent, you know very well the slope of normal. Normal slope is minus t. You have the point, you have the slope, you can write the equation. Normal equation is y minus y1 is equal to slope into x minus x1. This is what exactly the normal is, y minus y1. Look at the tangent and look at the normal. Most of the important questions occur on these two aspects. So please look at them carefully. yt is equal to x plus at square, that is tangent equation. Normal is y minus 2at is equal to minus t into x minus at square. Now let us work out some examples on tangent normals. You will understand how powerful this t is. So let us take some of the questions. Please see. Question 1. If tangents at t1 comma t2 meet at a point P, find coordinates of P. Okay, this is the question. I read the question again. If tangents at t1 and t2 meet at a point P, we'll just see, find coordinates of P. Did you understand the idea? The idea is, this is a parabola. We have drawn tangent at t1, we have drawn another tangent at t2. These two are meeting at a P. We have to find the coordinates of P. T1 means at1 square 2at1. T2 is at square 2at2. Please remember these two things. T1 means at1 square 2at1 and T2 is at2 square 2at2. Now let me work out this. It's a simple thing. If you remember the original result, tangent at T is yt is equal to x plus at square. We have seen this. Tangent at T is yt is equal to x plus at square. At T1, this changes to yt1 is equal to x plus at1 square. At T2, this changes to yt2. Just simply put T1 and T2 in the place of T. In the place of T, just keep T1 and T2. That's it. Now you got tangent at T1, tangent at T2. If you solve these two equations, you will have y coordinate and x coordinate. I am subtracting them. Y into T1 minus T2. While subtracting, x is cancelled, and a T1 square minus T2 square. If you factorize it, y will be a into T1 plus T2. This is y. Your y coordinate is a into T1 plus T2. And if you take, most of the geometrical properties can be proved by these parameter coordinates. That is why they are very, very important. Now if you calculate x, it will be a T1 T2. How do you calculate x? Just put the value of y here. You will have x. Let me show you how it is done. I am putting in this is my first equation. My first equation is yt1 is equal to x plus at1 square, and in the place of y I am putting y coordinate a into t1 plus t2 into t1 is x plus at1 square. Now a t1 square plus a t1 t2 is x plus at1 square. This is left over, your x is at1 t2. Therefore the tangents meet at a t1 t2 and a t1 plus t2. A t1 t2 and a t1 plus t2. Please look at this carefully. This is very important. Now sometimes they ask you the pair of tangents. Pair of tangents, how do we find? Later on we will see. First, this is the thing. I will work out another important question. Question number 2. Please look at this. I am working out on normals and tangents. These are very important. And now we are taking another question on normal. This question is a long answer question, and it's appeared many number of times. So please concentrate. The normal, I write the question carefully. The normal at T1 on y square is equal to 4ax meets the curve again at T2. If at T2, then show that, just simply then show that T2 is equal to minus T1 minus 2 by T1. This is the result they asked. A long answer question, 7 marks question, very important. Just please have a look at this. The normal at T1 on y square is equal to 4ax meets the curve again at T2, then show that. Sometimes this is asked as T1, T2